Okay, today we're on Chapter 1, Functions. This is Section 1.3, Rates of Change and Behavior of Graphs. So rates of change, what does that mean? Well, we're changing something over time. So the description of how output quantity changes relative to the change in the input quantity. And so the units are output units per input units. And the average rate of change is equal to basically our change in output divided by the change in input. And then we have this delta y, and delta means change. So it's the change in y over the change in x. And if we write that out based on the ordered pair, if we have the ordered pair, x1, y1, and x2, y2, then it's going to be y2 minus y1 divided by x2 minus x1. Or if you remember, when we have y's with functions, those are f of x of some sort. And so it's going to be f of x sub 2 minus f of x sub 1 and divided by our x2 minus x sub 1. And so, we're just taking and plugging x2 into f and getting out the y2, or we can just write it as the function here. All right, so what we want to do is find the average rate of change. And so how do we do that? Well, here's our function, and we want it on the change from 1 to b. Okay, and so what we're going to do is we're going to plug in the b, it's the second one here. We'll plug in 1 here, and then we'll have b minus the 1 here, and that's how we're going to work it. So let's plug things in. So we have basically f of b minus f of 1 divided by b minus 1. So when we do that, f of b, well, that's going to be 4 times b squared minus 7, and that's going to be our first piece here. And then we're going to subtract off f of 1, so that's going to be 4 times 1 squared minus 7. And so then that's all going to be divided by our b, which is, in this case, b minus 1. And now we just have to simplify. So this is 4b squared minus 7. And then minus, and if we want, we're going to go ahead and keep parentheses. And this is going to be 4 times 1 squared, which is 1. So 4 times 1 was 4 minus 7. And so what do we have here? 4 minus 7, that's going to give us, basically we have now 4b squared minus 7. So 4 minus 7 is minus 3. Minus a minus 3 is going to be plus 3 all over, and then we still have b minus 1. Now if we simplify, let's come over here so we have space. That's 4b squared. And minus 7 plus 3 is going to be minus 4 all over b minus 1. Now I see there's a common factor here, so because we might be able to cancel, we always have to factor as much as possible. So we factor out a 4 and we get b squared minus 1 all over b minus 1. Now if you notice, this is a difference of squares, and so that's going to be 4 times b plus 1 and then b minus 1 all over b minus 1. And so when we get done, what happens is our b minus 1 cancels b minus 1, and we just get 4 times b plus 1, and that then is the average rate of change over the interval 1 to b for the 4x squared minus 7. And again, it's just plugging in numbers or values, letters, whatever it is, and then just simplifying until you get your final point here. In this case, 4 times b plus 1. Well, what about this one? Well, we're going to do exactly the same thing. We're just going to plug in items and then just chug and plug until we get to the final value. So if we take f of the second part, which is x plus h, and then we subtract off the first part, which is f of x, and then divide that by our second part, which is x plus h, and then minus our first part, which is x, what do we get? Well, if we plug in x plus h into this, we're going to get 2 times x plus h squared plus 1. And then we'll have that all in parentheses so we can keep track of it. And then we're going to have minus. And then we plug in x here, we just get 2x squared plus 1 all over. Now here, x minus x, those cancel, and we just get h in the denominator pretty much from the start. Okay. Now we have to square x plus h, and when we square that, that's going to give us x squared plus 2xh plus h squared. And so we can replace that here, and then we take 2 times that. So we're going to have 2 times x squared plus 2xh plus h squared. And then minus, now if we go ahead and distribute the minus through here, that's going to be minus 2x squared minus 1. All right, and so now what we have, that's still all over our h. Okay, and so now let's make sure I have everything. I've got everything. 2x squared plus 1. That's 2 times 9 plus 1. All right. Oh, I forgot this. That's what I did. There's still a plus 1 here. So then let's go ahead and we can just put that plus 1 on the end. So I forgot to do that. I was making sure I had everything. So this goes to this. The 1 goes at the very end, then minus that in the middle. Well, notice now that this cancels this, so now we've simplified a little bit more. And at this time, we're also going to distribute. So that's going to give us 2x squared plus 4xh plus 2h squared. The 1's cancel, and then we have a minus 2x squared, and that's all over h. Well, notice now we have the 2x squared cancels here. So let's go ahead and maybe we should write down everything that cancels. And so that cancels that. Then 2x squared and minus 2x squared cancels. And so now what we have is 4xh plus 2h squared all over h. Now we can factor out an h in the numerator, and we have 4x plus 2h all over h, and now we get to cancel again. So that h cancels here, and it looks like we just get 4x plus 2h. And so that is going to be our value when we do it over the interval x to x plus h. And so that would be what our rate of change is. All right, what about this one? Well, again, we're going to do just like we did last time. We're going to plug in the 9 plus h first, and then we're going to subtract off the 9 part and go from there. So what we have is, if we want to write it out, we have f, oh, I guess it's a now. We're not doing f's this time. So so we have a of 9 plus h and minus a of 9 all over 9 plus h minus, and then 9. Okay, and so what does this give us? Well, now one cool thing is it looks like this cancels this already, so we just have h in the denominator again. Now when we plug this in, we get 1 over, then t is now 9 plus h plus 4, and then we have minus 1 over, and then now 9 is what t is, so it's going to be 9 plus 4, and then that's all over, and then we just have our h. Okay, so now we simplify. 9 and 4 is going to be 13, so it's going to be 1 over 13 plus h minus 1 over, and this is just going to be 13, and that's going to be all over our h. Now, what do we want to do? So now we can multiply and get common denominators. We can do, I don't know which one's the best one. Maybe let's get these two and add them together. And so if we add them together, we have to get a common denominator, which is going to be 13 plus h times 13. So it's going to be 13 times 13 plus h. And so then we're going to have on this one, to get that common denominator, that means we have to multiply this by 13 over 13, and this one by 13 plus h over 13 plus h. So that gives us 13 minus, and then we have here 13 plus h times 1, so it's going to be that, and then that's all over 13 plus h, oops, I'm a little h, and then times 13. And then we have this over h again, so that's kind of like times 1 over h. And so here we have, to simplify, so that's 13 minus h over, now we have 13h times 13 plus h. Where'd that h go? And 13 minus 13 is 0, so we have a minus h over 13h times 13 plus h. And we get a cancel again, it looks like, because our h here cancels this. That leaves us with 1. And so our final answer is then a negative 1 over 13 times 13 plus h. Okay, so this is one of the more complicated ones because you have fractions and you have to get rid of and add like denominators, get those, and then from there we could simplify and we get down to our final value for the rate of change, which is negative 1 over 13 times 13 plus h. All right, we can also find rate of change from a graph. And basically what we're going to do is we look at the point of wherever they're asking. So in this case, it says estimate over the range x equals negative 4 to x equals 0. So what we have to do is we have to figure our units. So that's 1, 2, 3, 4. So negative 4, that's going to be that point right there. Well, stay there. And then 0, x equals 0, that's that point right there. Okay, so we have those 2 points, and we want to find the rate of change for those 2 points. Okay, and so we're going to take basically the second one, which here is going to be the change in y's. So the y here is 4 minus the y here, which is 0, divided by the x here, which is 0, minus the x here, which is a negative 4. And so that gives us 4 over, and then minus a minus 4 is 4. And so that's just equal to a 1. Okay. Again, all we're doing is changing y over changing x. And so here we're going from negative 2 to 1. So maybe on our thing here, maybe we'll make a different color. So we're going from negative 2, so 1, 2, about right there, to x equals 1, which is, looks like that right there. Okay. All right, so here our first y is going to be, it looks like a negative 5, minus our original y, which is 0, all over our first, or our second x, which is at equal to 1, and then minus, well, actually, I don't know why I did that. Negative 2 is right here, so that's, I totally messed this up. I don't know what I was writing over here. So we'll just start over. Have to pay attention to what you're doing. So from negative 2, 1, 2, that's negative 2, and so that is the 1. So that works better. All right, so again, now we're going from negative 5 minus, and here negative 2 gives us a negative 2. And then we have our x, so it's going to be 1 minus a minus 2. And so this is going to become plus, a minus is plus, so minus 5, that's going to be minus 3. Over here we have 1 plus 2, which is 3. And so that gives us a minus 1. If we think about it, going down, that should give us a negative slope. And the other one, we were going up, and so that should give us a positive slope for our change, and that makes sense. So if you end up with something that doesn't jive with how this point to this point looks, or from this point to this point, you might have put your numbers in the wrong order, or like I did, you used the wrong value altogether. So be aware of what you're doing there, and hopefully that will be something that will be pretty easy as far as getting numbers off the graph. Sometimes the graphs you'll find, like we'll see later, they're not always easy. All right, we also have tables we can use. And so here we can find the rate of change from the table. And so this table gives the population of a town in thousands from 2000 to 2008. And what it asks for is what is the average rate of change in the population between 2002, so our first one is going to be from here, and to 2004, which is here, okay? And so what do we have? Well, now if you remember, this is going to be our input. So this is kind of like our X. This is going to be our output. And so that's going to be kind of like our Y. And so if we do the change in Y, we'll take our second one, 77, minus our first one, which is 83, divided by, now we have our X, which is 2004, minus our first one, which is 2002. And so now we simplify, and to get 77 minus 83, so that's going to be a minus 6, and 4 minus that's going to be 2. And if we divide 6 by 2, that's 3, and it's going to be a negative. So that's negative 3. And remember, it's the rate of change, and so we have to get the right unit. So it's going to be minus 3,000 people. Oops. I guess I could write peeps. 3,000 people per year is what the rate of change is. So we're losing 3,000 people per year from 2002 to 2004. All right, so let's do a different color for the second one. The second one says from 2002, so we're going to go from 2002 to 2006. All right, so here the second one is 78 minus 83 again. And so now we have 2006 minus 2002. So now 78 minus 83, so now it's one less, so it's a minus 5 over here. 6 minus 2 is 4. And so now we have to take 5 divided by 4, it's 1.25. And so it's going to be a negative 1.25, but we have to multiply by 1,000, so we move our decimal. So it's going to be a negative 1,250 people per year is how this rate of change is going. So over a longer distance, the rate of change is less. Over the shorter one, it's larger. So it all kind of depends on your numbers you chose. You know, going from 2000 to 2008, it's going to be a pretty small rate. But from here to here, that's going to be like the biggest one if we went to 2005. So it all varies. Just pick the numbers that they give you and make sure you do the math right. You should get these correct off the table. They're pretty easy. Okay, now we're back to ones where we actually have to plug in values again and find the rate of change over a given interval for that function. And so here we have g's, and so what we're going to do is we have 3, so we're going to take g of 3 minus g of a negative 3 divided by, and then we just take 3 minus, and then we have a minus 3. Okay. Well, if we plug in 3 here, that's going to be 3 times 3 cubed, and then we have minus 1, and so that's the first part, minus, and now we have 3 times a minus 3 cubed, minus 1, that's the second part. And that's all over 3 minus a minus 3, or 3 plus 3, which is 6. Okay, so now we just have to do some simplification. So here we have 3 times 3 is 9, times 3 is 27, times 3 is going to be 81. And then we have minus 1, then minus. And here we have the same thing, except it's going to be a minus 81 minus 1 all over 6. Well, 81 minus 1 is 80. 81, negative 81 minus 1 more is a negative 82. But remember, it's this minus this, so that really becomes plus. So 80 plus 82 is 162 over 6. And if we divide out, let's see, 6, will that go in there? If we do 2 times, and that's 42, that's 7. Okay, so that'll work, and that's 27. So that's going to be our rate of change for going from negative 3 to 3 on the interval for this function here. Okay. All right, so let's erase this. And how about the next one? All right, so this one we're going from -3 to 1. So we're now on p's. So p of 1 minus p of -3 all over 1 minus a -3. Well, 1 minus a -3, that's going to be the easiest part. That's going to give us just 4. Now, if we plug in 1 here, we'll have, now this is going to be more complex. So we have 1 squared minus 4, and then times 1 plus 1 over 1 squared plus 3. And then we have after that minus, and then we'll have a little bit more space. And so now we're going to plug in -3 here. So it's going to be a -3 squared minus 4. And then we'll have a -3 plus 1 all over. And here we'll have -3 squared plus 3. Now, if I can read all that when we'll go back, well, 1 squared is 1 minus 4. So that's going to give me a -3. Oh, wait, yeah, okay. 1 minus 4 is -3. And then we have 1 plus 1 is 2. And then that's all over 1 plus 3, which is 4, minus, and now here we have a -3 squared, so it's 9, minus 4 is going to give us a 5. And then we have a -3 plus 1, so it's a -2. And then we have here a -3 squared, so it's a 9, plus 3, so it's a 12. And then that's all over 4. All right, so that's going to be a -6 over 4. Minus, and then we have, or we could do plus because it's a negative, so it'd be a plus, and that'd be 10 over 12. And that's all over 4 again. All right, so now we get a common denominator here, so that means we have to multiply by 3 over 3, so that's going to give us a -18 over 12 plus 10 over 12 divided by 4. And that's going to give us a -8 over 12. And remember, if we multiply this by 1 over 4, multiply the whole numerator times 1 over 4, that's what we have. And now we can reduce, it looks like a little bit. So 4 will go in here once, 4 will go in here twice. Oh, we get to cancel again, so let's change a color again. Well, 2 will go in here once, 2 will go in here 6 times. And so I guess let's leave it that color. So it's going to be a -1 over 6. Okay. And so then that is going to be our rate of change for this function on the interval from -3 to +1. So a lot more work on this one, but again, it's simple math. It's just making sure you keep track of everything as you go down, and that's going to be the hardest part. All right, we can use graphs to determine whether the function is increasing, decreasing, or constant. So a function f is increasing on an open interval from f of b is if f of b is greater than f of a. So basically, if we kind of look at this, you know, if we're going from -5 up to the 2, so any point that's to the right, and say this is a point here, and if as long as that's greater than the point here, that means it's increasing. So this one, all the points f of b are greater than f of a. Okay, so the point B has to be to the right of A. So that's the key here. So that's what it shows. Now in decreasing, what's going to be happen every point over here, so say we have this one, that's going to be less than this point. And so this is a decreasing part of the function. And then here again, every point to the right is going to be bigger than the point here. And so we're back to an increasing function here. And the decreasing function, I didn't mention that one. Basically, your f of c has to be less than f of b. Well, I was using a's and b's on all of them, so you could use either c's or a's. But either way, this one over here has to be less than the one on the other side. So basically, as you move across, the right one has to be, in this case, less than the left one if it's going to be decreasing. All right, so the function has a local maximum, maximum being the biggest, at a point B in an open interval A to C. So if we look here, this is kind of what it's talking about. We have the interval A to C, and we have some point B, and basically what it says is that the f of B, whatever that value is, in this case, your y value, is going to be greater than any other f of x for any x you find over here or any x over here on the whole interval, except for at the point B, it's going to be the largest one no matter what, okay? And so that means it has a local maximum. And so the local maximum, the value of the input where a function changes from increasing to decreasing as we go from left to right. And as you notice, that's what happens. We're increasing part of the function here, we hit that local maximum, and all of a sudden after that, we're decreasing. And that's what it means. That's the point where it changes from increasing to decreasing. Now, a local minimum is kind of the opposite. It's going to be kind of more like this point here, okay? And so basically what's happening is at that point B, all the other x's, so if we go from 0 to, I don't know, 3.7 or something like that, all the points in between here, all of those are going to be greater than that f of b is, okay? So all values are going to be, for b, are going to be less than whatever that value for f of x is that is going to be higher, okay? And so the local minimum is the value of the point where it's changing from a decreasing function, decreasing here, switching over to an increasing function. So that's going to be called our local minimum, okay? And we also have things called local maxima if there are more than one maximum, and basically it's just a plural, and we have local minima if there's more than one minimum, which is also the plural version of it. So if we look here, we have a local maximum here, and we have a local minimum here, and we have, the functions increasing, hits that local maximum, then it decreases, hits that local minimum, and then it starts increasing again, okay? And so the local maximum basically is your y value, the 16, and it occurs at where? Well, it occurs at -2. Whereas the local minimum, its value is -16, which is the y value, that's the local minimum, and it occurs at x equals 2. Okay, so those are kind of key points on how local minimum, local maximum work. And so what we can do is, I'm using Desmos here, and basically in Desmos, and it's just desmos.com, and you can plot any kind of graph you want to here. It's really nice. You just hit the graphing function, and I just typed in the function they gave here. So I didn't have to plot points or anything. I just said, what is it? And it spits out my nice little graph here. So much better than I can hand draw. And it says, graph it to find the local extrema, and then determine the intervals where the function is increasing and where it's decreasing. Okay, so what does that mean? Well, what it means is we're going to have to figure out where those local maxima, local minima are, and then it's going to have to figure out where the intervals are for increasing, decreasing, and back to increasing. So this is going to be a local maximum. And if you notice this, that's going to be a local minimum, okay? And so that means it's going to be increasing up to the point of that local maxima. And so at this point, if I can write this, so that's increasing there. And so then that means after that, it's going to be decreasing. So let me see if I don't know if I can write this. We'll just say decreasing like this. And somehow my D didn't match. And then after you hit that local minimum, then it goes back up again. And so it's increasing once again, okay? So we found the extrema, this is it. And so the extreme value is at 28 when x is -1. And here, the local minima is -80 when x is equal to 5. So local minimum is -80 at x equals 5, and the local max is 28 at x equals a -1, okay? Now we need the intervals. And so the intervals are, well, if you think about this, this is just going to continue going on forever and up forever. So really, these should kind of have arrows on them. But when you copy from Desmos, it doesn't give you the arrows. It just keeps a line going straight up forever. So we're increasing, and we're going to go from basically negative infinity, because as you go down this way, it's just going to keep going out to the left. And so we're going to go from negative infinity, and then it stops at that point here. And so that's to -1. Now we don't include the -1 because it's not one of the actual points. That's the local maxima at that point. Now after that it starts decreasing. So let's go ahead and start our decreasing part. And so it's decreasing from -1. Again, we don't include it. Up to, and then we go all the way down here. Well, this is where the max is, and so it goes up to 5 where it's decreasing. It doesn't include 5. And now it starts increasing again. So now we need to have a union. And now we're going to start at 5, and now it's just going to go up to positive infinity, because as you go up, it keeps going to the right, and it's just going to go forever that direction. And so we found the local maxima is 28 at x equals -1. Local minima is -80 at x equals 5. It's increasing on the interval from negative infinity to -1, union 5 to positive infinity, and it's decreasing from -1 up to that 5. Okay, and again, I just used Desmos.com, plugged in this, and it spits out my graph, and I don't actually have to hand plot all those points. So, you know, your graphing calculator will do the same thing, and you could see those points from there as well. So if you've got a TI-84, you can do that. So let me see if I have this written down. I better write it down, and then I'll show you on the graphing calculator what that looks like. And so that's going to be x cubed minus 6x squared minus 15x, and then plus 20. So let's go to our graphing calculator, and that is right here. And so we just plug it in at this point here. And so if we clear that, then we can type in our x to the third, then arrow down so you don't get that, and then minus 6x squared, and then minus 15x, and then plus 20. And we see our graph, and I don't know what my scale is, so I guess I should do that. So if we go down and say that's -10, and maybe say that's, actually we'll need to be higher. Y max has to be 40 at least, probably, and we'll go and do that -40. Now let's see if that's good enough to get a whole graph. Not yet. That was -80, sorry. So let's do a -90. All right, and so then that's kind of what it looks like, and it goes up and down. And then you just have to, on here, you'd have to do a trace and just kind of work here. And at this point, then there's some features in your calculator that you can use to actually find what that maximum is. But at this point, that's not part of what we're looking at here, because that's not how we need to do that. But the way to do that is we need to do second and calc, and we want to find the minimum, and so 3, and our minimum is going to be this feature down here. And so what you have to do is find a left bound, hit enter, find a right bound, hit enter, and we're just going to guess at the right bound. And as you see, we get the 5 -80, which is what we had on the other one. And we could also do the second calc, do the maximum, which is 4, and then that one is going to give us the -128. So that's that one. That's that one. We'll guess that, and it's -1 and then 28. So it kind of rounded it there, but it's still a -1. All right, so that's kind of how you can use your calculator versus if you just type it in Desmos, and then you can just click on the graph and it'll give you the values. All right, now absolute maximum. So the absolute maximum of f at x equals c is f of c. Okay, so basically you're just plugging in c for the x, and then that's where f of c is greater than all f of x on a whole domain of f. Okay, And the absolute minimum of f at x equals d is f of d, where f of d has to be less than or equal to all f of x for all x in the domain of f. Okay. And so what we're going to do here is we want to find the absolute mins and maxes on this graph, as well as find the areas where it's increasing and decreasing. So we've kind of done this before, but this is kind of an actual plot out of, I think, the book actually. So what we need to do is kind of figure it out. So absolute maximum is going to be about, oh, that's not the absolute max, that's just a maximum, a global. So we want the absolute max because notice over here it actually ends. I forgot it ended. So you have to be careful of that. So the absolute max is going to be this because it actually ends at that point, and the absolute minimum is going to be this one because it actually ends at this point. And so those are the points we have to actually figure out where they are. So if we come over here, that's about at that point there, which is somewhere maybe 220, negative 220. And this one looks to be at 150, so that's okay. And so this point here looks to be about 7, 150. And this point looks to be, well, that would be 7. Our absolute max is going to be 7, 150. Okay, as long as we have these numbers close. All right, so now what we need to do is figure out where it's increasing and decreasing. So it's increasing from, if we said that's negative 7.5, then it goes up to, at this point here, which is a kind of a global max. It's not the absolute, it's one of them. And so that's about, it looks like maybe 3 or so. I don't know, we'll call it 3. And so then it starts decreasing to here, which again looks to be about 3. So we'll go say it's decreasing from negative 3, actually that's a negative, sorry, to a positive 3. And then at the positive 3, it goes back up. So we're going to have another union, and we're going to go up to 7 because we said that was 7. So again, this is about as good as we can get based on this graph as far as what we can see, what we cannot see. So again, I think it's going from negative 7.5 up to the negative 3, and then it's going from positive 3 up to 7 for the increasing part, and it's decreasing from negative 3 up to the 3, and then we have our absolute maximum, which is 7,150, and our absolute minimum, which is negative 7.5, negative 220. Okay, and so that's all I have for section 1.3.